All right, 3.7, solving exponential equations. Okay, objective, students will be able to solve exponential equations using common logarithms and natural logarithms. So we've already played with common logs, but I just want to remind you what a common log is. That's a log with a base of 10. So we just write that as log x. So log 10x, we just write that as log x. Okay, that's a common log. Then what we really want to focus on this one is what we call natural logs. So there's another type of logarithms that we have to get to use. It's called natural logarithms, okay? Natural logarithms use this number e, or Euler's number, but we just call it e. And e is just this interesting irrational number that shows up in the world of mathematics frequently. It just shows up a lot. And so here is e, as many decimals as I could fit on here. It's just this weird number that goes on and on forever. But it's really about 2.718. Okay, it's about that. Just like pi is about 3.14, e is about 2.718. Now, this is not really what's really crucial about this, okay? I just want you to understand what e is. It's just this number, okay? What's crucial about this is now we're going to have things that say e to the x equal y. Well, when that's true, we could write it as a log, the same way we've been writing logs before. We could say log, and e is the base, so the base would go down here, and switch the y and the x, the y and the x. Well, so we can do that, but whenever we have log base e, we need to replace it with ln. So you don't write the base e, and you don't write the log, you just write ln, okay? So basically, anytime you see a log base e, that's the same thing as ln, okay? So just know that you replace log base e with ln, and then you would just have ln of y equals x instead of log base e of y equals x. Okay? So, now that we've done that, let's practice it a little bit. First, let's just practice converting these exponential equations into logarithm form. So, like we did before, I would make e the base, so let's just go ahead and write the log out. Log, e is my base, switch the 2 and the x. Okay, remember though, I don't want log base e, right? Whenever I see log base e, I'm going to replace that with an ln, just like I said over here. So, I'm going to write ln of 2 equals x. And that's all there is to it. That's how we rewrite using an e. Okay, I want you to go ahead and try this one. So pause the video and then come back when you're ready to check your work. Okay, so you could have written it like this first if you wanted to, but hopefully we'll stop using that whenever we see the e and we'll just go straight to natural log. But this is fine. You could have written like this at first and then said, hey, you know what? When I have a log base e, that's the same thing as ln, so just replace that with ln of m equals 3. And technically you could have little parentheses here because this is the log base e of m, or the natural log of m. So we could do that, but you don't really need the parentheses there. Okay, so now that we've practiced just converting it, let's use it in solving an equation. So here's one right here, and I'll give you guys a little side note. It says, remember, get the base that is being raised to the power of x, so e of x or a to the x. We'll do some a to the x in class. Alone first, then convert it to the logarithm form and solve. So let's get this e to the x part first. Get that all by itself first. So to do that, I'm going to add 4. So I'd have 2e to the x equals 4. Then I'm going to divide by 2, and so now I have e to the x equals 2. Okay, so I've done everything I can to get it all by itself. Now it's time to go ahead and switch it to the natural log form. Okay, I don't have to write the log every time. I could just write natural log, since it's a base e, and I just switch these two. So it's natural log of 2 equals x. So that is considered a solution right there. Like, that could be done. But sometimes they'll ask for a decimal answer. When they ask for a decimal answer, you need a calculator. And your button should have an ln button or a natural log button. So all you have to do usually is just press natural log of 2 equals, and you get a decimal answer. And I'm getting a decimal answer of 0.6931 approximately. So that's the decimal answer. So this is the exact answer, this is the decimal answer. Typically we prefer this, but sometimes I'm going to ask you for decimals as well. Okay, so now that we've done that one, I want you guys to try this one on your own. Remember, get the e to the x all by itself first, then go ahead and solve it. And then unpause the video when you're ready to check your work. Okay, so I added 20, and I got 21. 3 times e to the x equals 21. Divide both sides by 3, and I got e to the x equals 7. Then I went ahead and converted to log form, or natural log form, because the base is e. And so I switched the x and the 7, and there we go. The ln of 7 equals x. So this is my exact answer, and if I plug it into my calculator, I should get this decimal answer. So I would go ahead and check, double check, make sure you can get this in your calculator. All right, let's do some ones that are a little bit more fun. So same idea, we need to get this part all by itself. Even though there's some more going on here in the variable, that's okay. Our natural log will take care of that for us. So first things first, divide both sides by 2. Now we have e to the 0.25x equals 3 halves. And whenever I see a decimal, if I can rewrite it as a fraction, I'm going to try to. Maybe I'll wait a second to do that, but just know that like when I see decimals, I'm going to see if I can rewrite it as a fraction. If I can't, no big deal, I can leave it as a decimal, but usually if I can write it as a fraction, it's going to make my life a lot easier. So let's go ahead and write this as a natural log. Okay, so e is my base, but I don't need to write it, and then I just switch these two. So this would be like the natural log of 3 halves equals 0.25x. And this is where I'm thinking that maybe if I could write this as a fraction, I'd be in better shape. Because 0.25 is the same thing as 1/4 x. So I really have the natural log of 3 halves equals 1/4 x. Well, now the reason why I wrote this as a fraction is because if I did it as a fraction, I have to divide by 0.25, divide by 0.25, it would just look messy. But as a fraction, if I want to get rid of this 1/4, I realized that I could just multiply both sides by 4. And that cancels these out, because 4 times 1/4 is just 1, so I get x. And so I get 4 ln of 3 halves, or you could say 4 ln of 1.5. Either way, we have our exact answer. Now we're ready to go to our calculator. And 4 ln of 3 halves is 1.6219 approximately. Okay. So that's all the same thing. I just wrote it here as 1.5 to show you it's the same thing, and that's our decimal answer. So these are our exact, this is the decimal. All right. I do want to point something out real quick. I know this problem is done, but we can change quite a bit of how we write this. I want to remind you that, remember the properties that we had when we're dividing on the inside, the same thing as minusing? So we could have said this as 4 ln 3 minus 4 ln 2. And then remember that we said before that the number in front could be written as an exponent. So we also could have written this as ln of 3 to the 4th power minus ln of 2 to the 4th power. Well, you could go ahead and evaluate that. And I'm just showing you how this will work because I'm just playing with it so you could see the patterns going on here. So 3 to the 4th power is 81. So this is like saying ln of 81 minus 2 to the 4th power is 16. So this is like ln of 16. So this would be the same thing as if I was to plug ln of 81 minus ln of 16 in my calculator. I should get the exact same decimal answer. And I do. When I plug that in, I still get 1.6219. I'm just kind of showing you how you might be able to rewrite these in different ways depending on how they're asking for the question, asking for the answer, right? This is an answer, this is an answer, this is an answer, this is an answer, this is an answer. And actually also, since they're minusing on the outside, I could say this is an answer as well. These all equal the same thing, okay? Usually this will suffice. I just want you to see all the different ways that we can write the exact same expression here. So, all right, one more problem. Hopefully I didn't confuse you too much with all those different ways, but I just want you to see all the possibilities. And I want you to try this one on your own. So get the e to the 0.1x all by itself, and then rewrite as a natural log, and try and solve. Remember, if you can write that as a fraction, it might help you. Okay? Go ahead and give that a shot, and then unpause the video when you're ready to check your work. Okay, so I divided both sides by 7, and I had this, and I wrote it as a natural log, making this natural log base e, right? That's what that means. Switch these two things, so you get a 7 and 0.1x. And then I saw that 0.1 is really the same thing as 1/10. So I went ahead and wrote it as 1/10, and that means that I can multiply by the reciprocal, which is 10, to both sides, and I'll cancel those out, so I just have an x over here. Now I have 10 ln 7. Now this is important. Notice I put the 10 out in front. What I think that you guys might do, which is wrong, is you might write this as ln 7 times 10. Well, the reason why that's wrong is you'll think that that is ln of 70. And ln of 70 is not the same thing as this, right? So that's why I'm writing whatever I multiply out in front. That's where it goes. It doesn't go on this side. So make sure you leave it in the front and don't do this. Because the ln of 70 is something totally different than 10 ln of 7. You could check in your calculator and see they're two different values. Okay, so anyway, when you do 10 ln 7 in your calculator, you get 19.4591. And there you go. All right, so we've done all those. Like I said, we'll do some with a to the x in class, but that's what I wanted you guys to see using the ln of x. So I'll see you guys on the next video.